think it's going to be 3 problems. Yeah, maybe. No, what the heck? Get 4 problems. No, you're not graphing. I don't think you're going to graph. Why, do you have to graph on the homework?
Yeah.
Huh? Oh! Oh, then you might have to graph. That's right, you have to graph a tilted parabola. Well, yeah, Mr. Park, I didn't even do it yet. Okay, con 2. Okay, which ones are we going over? 2. What the heck is that third number? That's a 4. Thank you for putting it in order. 2, 4, 5, 8. How come every year at number 2? This is like one of the easier problems. Okay, draw a parabolic arch. Okay, and then put it on the Cartesian plane. Now, where do you want to put the origin? The most popular places would be here. E1, A, B, C, or D. Doesn't matter. If I were me, I put it at B. Okay. Therefore, if it's 100 feet high, isn't the vertex 0, 100? And if you got the vertex, you can write almost the whole equation already, right? And then since it's 100 feet wide, wouldn't this point here be 50, 0? Yeah. Okay, so therefore the equation of the parabola is going to be, this is an up and down one, so x minus 0 squared is equal to 4p times y minus 100. How do I figure out what 4p is? Do we know where the focus is? No, we don't. The focus is somewhere up here somewhere. I don't know where it is. But we do know that it passes through this point, so you can plug this point into the equation to figure out 4p. So if you plug in 50 for x, what's 50 squared? 2500 is equal to 4p times, and 0 for y, you get y. Oh, no, plugging in 0 for y, fool. Negative 100. So therefore, 4p is equal to negative 25. That's this number right there. And that makes sense because it's opening down. So there's the equation of your parabola right here. And then it says, how high is the arch 20 feet from the center? So here's the center. If you walk 20 feet this way, how high is the arch going to be right there? Well, obviously it's going to be less than 100, but we needed an exact number. How do I figure that out? You use the equation of the parabola. If I plug in 20 for x, what is the y coordinate going to be? Call it box. So all you got to do is plug in 20 for x and solve for y. You guys can do that right now. I remember I gave this on a quiz one year. Somebody had like 150 something is the answer. How can it be above the arch? It's going to be below the arch. If the highest point is 100, the answer got to be less than 100. Because I think I changed the numbers. Instead of 100 feet high, I made 120 feet high and 80 feet wide or something. Okay, number 4. Write the equation. Oh, ooh, this is a good candidate for the quiz right here. Write the equation of the set of points in the Cartesian plane that are equidistant from the circle x squared plus y squared equal 1 and the line x equals 3. So here's a representative point, x comma y. What's the set of points that are equidistant from a circle and a line? Now you can probably figure out it's going to be a parabola, right? Why? Because it's on the parabola worksheet. Because what? Yeah, exactly. Some people say, oh, think of the circle as a big focus. No, that's not a point. You can't do that, okay? Anyway, so the distance between the point and that line is equal to the distance from the point to the circle. Okay, now, first of all, how do you find the distance between a point and a circle? Well, it's the shortest possible distance. How do I find the shortest distance from a point to a circle? Well, think about it. Okay, let's say you have a circle, and you're standing right here. There's like a race. The first person to touch the circle is the winner. Where are you going to run to? You're going to run like that. No, you're going to lose. Especially at your speed. What do? You run toward the center. Isn't that going to be the closest point? You aim toward the center. Doesn't that make sense? Okay, so the shortest distance from this point to the circle is you aim toward the center, like that. It's going to be this distance right there. This distance got to equal that distance. So how do you find the distance between a point and a circle then? Find the distance between the point and the center of the circle and then subtract the radius, which is 1. Doesn't that make sense? Okay, so this is 0, 0. How do you find the distance between here and here? Use the distance formula. And then subtract the radius, which is 1. Everybody understand that? The distance from a point to any graph, it doesn't matter what graph it is the shortest possible distance. And that has to equal to the distance from this point to that line. How do I find the distance between the point and the line? Do I have to use that formula? No, because it's on the... Look, if this is... I showed one class this because it came up in the other class. How come nobody asked about this one? If this is 2 and this is 5, do I need a formula to tell me that's 3? Yeah, you just go 5 minus 2, right? Right minus left, right? How come we go right minus left? How come I don't go right, left minus right? Because then you get negative 3. Distances cannot be negative. Just go big minus small. Okay, so what's the x coordinate right here? X. What's the x coordinate right here? So what's that distance? 3 minus x. Right minus left. And if it's vertical, if this is 1 and this is 4, do I need a formula to tell me that's 3? You just go 4 minus 1. I guess that's a formula, right? Top minus bottom. You just go big minus small, and that will give you the distance. And that way you don't have to worry about negative. Anyway, this is your equation, and then you guys can simplify it. Isolate the radical, square both sides, and then can you see the x squareds cancel out, so you're going to get a parabola. See, I'm trying to train you because for the test, I'm going to describe some conic section. You're going to have no idea what it is. But you have to write down. So if you don't write down this equation, it's pretty much a fatal error right there. Because if you put x minus 3 over here, when you add the 1, it's going to change, right? It's going to be something totally different. You got to make sure you make the distances positive. So that's why you go big minus small. Okay, you guys can do the algebra. And then number 5. Aha! Write the equation of the parabolas, which is saying that there's going to be more than one answer. So the endpoints of the lattice rectum are -1, -5, and -1, 7. How come there's 2 answers? Yeah, because the parabola could open to the right, or it could open to the left. Right? So that's why you're going to have 2 answers. So what happens if you only give 1? You're only going to get half the points, right? So I'll do one of them for you. Which one you want me to do? The one opening to the right or the one opening to the left? You sure? The one opening to the left is harder because you got to remember P is negative. Okay, now. Okay. Oh, so you just want me to do the hard one all the time? Okay, here's one parabola. These are the endpoints of the lattice rectum, so therefore, isn't the focus going to be halfway in between? So the focus is at, what's halfway in between, using the midpoint formula? -1, 1. Now remember, the length of the lattice rectum is 4p, yeah? In a parabola. So what is the distance? If you went from -5 to 7, how far did you go? Well, you just top minus bottom, right? Oh, so p is 3! So that means the distance from the vertex to the focus is 3. So if I go 3 to the right, where am I going to be? 2, 1. And once you get the vertex, you can write almost the whole equation. So this is a left-right parabola, so the y squared. Y minus 1 squared is equal to 4p times x minus 2. And we know p is 3, so just put 12 here. No, it's negative because it's opening to the left. And then the one that's opening to the right, then it'll just be positive 12, right? Except the vertex will be 3 units this way, right? You guys can do that, right? See, so you got to know all the parts of the parabola. You got to know that the length of the lattice rectum is 4p. You got to know the distance from the vertex to the focus is p. You You have to know that, not to extend to the problem. Okay, and then number 7. Oh, you guys did number 7. That's because we did this in the first quarter. Yeah? And very good. You guys got number 3. I'm proud of you. Getting choked up. You guys knew. See, if you're given 3 non-collinear points, just make up something, whatever. If you're given 3 non-collinear points, there's exactly 1 parabola with a horizontal axis of symmetry that passes through them. So did everybody plug it into this equation? Right? I'm just wondering because I'm just wondering if you guys did the homework. So just plug in these 3 points into this equation, right? Just got to pick the right equation, right? What if I said vertical axis of symmetry? Yeah, then you plug it into this equation. And then, of course, tomorrow's quiz is the circle, so then you plug it into this equation. I'm just spoon feeding you again. Right? So tomorrow, you take the 3 points and you plug it into that equation. And then you got to do the algebra. Okay, so number 8. Write the equation of the set of points in the Cartesian plane that are equidistant from the line, 4x plus 3y plus 2 equals 0, and the point 2, 1. What is it going to be? It's a parabola. That's the definition of a parabola, right? The set of points in a plane that are equidistant from a line and a point. This is the directrix. This is the focus, but can you see that it's off at an angle now? So the parabola is going to be like that. Tilted parabola. But what's the definition of a parabola? If this is a given, if this is a point on the parabola, it doesn't look like it. If this is a representative point, then what? This distance and that distance gotta be equal. They're equidistant. It means the distances are equal. How do I find the distance from here to here? Distance formula, square root of x minus 2 squared plus y minus 1 squared equals, how do you find the distance between a point and a line? Oh, you use that formula, which is the absolute value of 4x plus 3y plus 2 all over. Come on, you guys should know. What's the square root of a squared plus b squared? 5. Expect that you're giving me triple. 3, 4, 5. There you go. That's it. That's your answer. Except, now you got to simplify it. You got to square both sides, multiply both sides by 25. Just do a bunch of algebra. That's all it is. Well, you want me to do it? Yeah. Chai, your stuff just plummeted right there. Time versus chai stock. It just plummeted right there. Sharper than that. Look at it, it's the fake one. This is the real one. Okay, square both sides. X squared minus 4x plus 4 plus y squared minus 2y plus 1, okay, equals 25 on the bottom. Okay, now, I taught you guys how to square that. What is a plus b plus c squared? We talked about this in the first semester at least twice. What is that going to be? A squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc, right? That's just following the same pattern as this. A plus b squared is a squared plus b squared plus 2ab, right? It's the same pattern. Okay, so if I square this thing, you're going to get 16x squared plus 9y squared plus 4 plus 2ab, 24xy, plus 2ac, 16x, plus 2bc, plus 12y. Multiply both sides by 25, and then you can just make one side 0 and you're done, right? You guys can take it from there, right? Now, of course, if you don't know how to multiply it out, then just do the old barbaric method, right? The way you were taught in 5th grade. Take the first term, distribute it. Take the second term, distribute it. Take the third term, distribute it. It's up to you. See how this formula comes up so often? So is that it? Everybody got the polar one then? You guys got the secret now. See, I teach you guys the secret on the first day. It makes life so easy. And then when you get tonight's one with the ellipse, it's going to be even easier. Okay, so today we got to do ellipse. Did your teacher show you the string? Okay, let me get. Oh, by the way, before we even start, why do we even study parabolas, ellipses, and hyperbolas? And circles? Well, you guys in physics, you guys know why we study circles already, right? Are you guys on lenses yet? Who's in physics? Not one person is. Okay, why do we study parabolas? Just so teachers have jobs? Okay, here's a parabola. Gotta make sure this is on the camera. Here's a parabola. Here's the focus. Okay, here's the axis of symmetry. A property of a parabola is this. If you have light coming in parallel to the axis of symmetry, it's going to hit the parabola. Where do you think it's going to bounce off to? It rhymes with hocus. The focus. So anytime you have a light ray coming in, boom, it goes to the focus. Whoa, katoing, katoing. It always goes to the focus. How can we use this to help us in real life? You guys ever heard of direct TV? Yeah. Okay, so you take a parabola, and if you revolve it about its axis of symmetry, you get a paraboloid. Okay? Parabolic dish. Here's the parabolic. You guys don't know what a parabolic dish? They use this for radio telescopes too. You aim it to the heavens, right? And then all the whatever rays coming in. Okay, so like all the rays come in, they hit the parabolic dish. Where do they go? They go to the focus. That's why it focuses everything, and that's why they call it the focus. So if you were smart, where would you put the receiver? Yeah, you put it at the focus. Because if you put the receiver somewhere else, you're not going to see anything on your TV. And then the opposite is true too. Like, you guys ever heard of this thing called a flashlight? I just don't know what you guys. You open it. You guys ever opened up your flashlight and look inside it? How about when you put in the batteries? It works on batteries. You put the light bulb where the focus is. Okay, so the light bulb is placed where the focus is. Of course, the back is all. Do you guys notice it's shiny? You know why? Because you have the light from the bulb going out like this, but then all the light that goes back, what? It hits the shiny material and it comes out parallel to the axis of symmetry. That's why we study parabolas. Not just so teachers have jobs. Yeah, it looks like a jellyfish. Okay, now we're going to do ellipses. Ellipses have reflective properties, and so do hyperbolas. Okay, where's the string? I can't believe you guys never. Okay, I need. Just use duct tape. Oh, no, no, no! Let me use this kind of tape. Okay, looking at your notes or remembering from last year, what is the definition of an ellipse? It's the set of points in a plane such that the sum of its distances from two fixed points is constant. So what you have to do is you have to have two fixed points. Yeah, that's good. What are these 2 points called? A foci. You have one focus, but parabola has one focus and ellipse has two foci. These are two fixed points. They don't move, okay? The sum of its distances from two fixed points is constant. So if you ever want to make an elliptical table when you get older, a lot of people go into woodworking when they get older. This is how you make a perfectly elliptical coffee table. Okay? Put that there. Your teacher didn't show you this. It's in the book too. Every book has this picture in it. Okay? So if I pull the string taut like this, isn't this distance plus that distance going to be the same always, the length of the string? So this plus this is always constant. It's the length of the string. So no matter where I am, this plus this is still the length of the string. So if you take the set of all points, right? You're going to get an ellipse. Oops. There, you get an ellipse. What would happen if I put the 2 points further apart? What would the ellipse look like if I put it farther apart? Then it's going to more look like this. What if I put the 2 points closer together? It's going to be more circular. What if I put the 2 points at the same point? You're going to get a circle, right? Oh my goodness. You guys never saw this? Anyway, these are the two foci. If I draw a segment that goes through these two foci, what is that? What is that called? The major axis. What do I call the point that's halfway in between the two foci? Rhymes with center. The center! These are the two foci. This is the major, oh, I should have made it, what do you call this axis then? The smaller one. That's called the minor axis. These 2 points are called the endpoints of the major axis, but we have a name for them. They're vertices. The vertices are the endpoints of the major axis. And what do you call the endpoints of the minor axis? The endpoints of the minor axis, because there's no name for them. Okay, now, the standard equations of ellipses are this. They're in your notes, right? X minus h squared over a squared plus y minus k squared over b squared is equal to 1. Okay, now, you guys remember in an ellipse you have A, B, and C? A represents the distance from the center to the vertex. So this is A. B is the distance from the center to the endpoint of the minor axis. That's B. And C represents the distance from the center to the focus. That's what C is. You got A, B, and, but I don't see any C, Mr. Park. That's because to get C, does this sound familiar? C squared equals A squared minus B squared? Yeah. So in an ellipse, C squared is A squared minus B. Anyway, these are the three distances you got to know, right? Because when you draw an ellipse, right, this is A. This tells you how much to go left and right, right? This, when you compute B, that tells you how much to go up and down, and that determines the shape of the ellipse right there already. So you can surmise already that A is the bigger denominator, right? A squared is always going to be the bigger denominator. B squared is the smaller one. So if the bigger number comes under the x's, that means the ellipse, the major axis is horizontal. But if the bigger number comes under the y's, like that, A squared is always the bigger one, huh? Then the major axis is going to be vertical, right? Because you got to go bigger number up and down, right? Doesn't that just make sense? Okay, so let's look at a problem. Because you guys got to learn how to find all the different parts of the ellipse. Oh, and by the way, why do we even study ellipses? Just so teachers have jobs? No, because they have reflective properties too. Okay, let's say you have a light ray over here, or some, I don't know, whatever, sound or whatever. If you go out, it hits the ellipse, where do you think it goes? It gets reflected to the other focus, like this. Ka-doing, ka-doing, ka-doing. So what do we use this for? Whispering chamber. You ever heard of a whispering chamber? You guys ever go to like science museums? You guys ever go to museums? You guys ever heard of a museum? I've been to several science museums. Okay, you walk up these steps. It's like it's like a, okay. It's like you walk up here, and then your friend is like he's like 50 yards away. It's like super far away, you know, over there. And then you guys can just be kind of talking kind of soft like this, but you can hear them perfectly. You know why? Because they have like a elliptical thing there, and they have an elliptical thing there. All the sound waves that go out get reflected where? To the other focus. Like that. So that's why you can just be talking softly, but 50 yards away you can hear it perfectly clear, because that's the other focus of the ellipse. It's called a whispering chamber. And you guys are in U.S. history now, 11th grade, right? You heard the story of John Quincy Adams, right? I believe he's the 6th president of the United States. What's this? Come on, every history teacher knows this. The picture is in every book. John Quincy Adams is like in a seat over here, pretending to be asleep, like this. That's what the picture looks like. I'm pretty sure it's in your history book. And then the other party, you get like 5 party members over here talking, and he can hear everything. Because in the Capitol building, I don't know, it's like elliptical shaped. So everything that's said over here, the thing bounces up and it goes right over there. Did you guys ever go on the tour of the Capitol building? Not one person? How many people have heard of the Capitol, Washington, D.C.? They have the building called the Capitol building. You guys never went on the tour? Not one person?
I did.
And they never mentioned that?
They did.
That's what I'm saying. And did you ever wonder, did anybody ask why? Because it's shaped like an ellipse. Okay, anyway. Oh, and I already told you what's the other application of ellipses. When planets go around the sun, here's the sun. When the Earth goes around the sun, the shape of the orbit is an ellipse. The sun is located at one focus. The other focus, now they're pretty close together. The two foci are close together because the orbit of the Earth is very circular. It's not a circle, it's elliptical, but it's circular. So that means the two foci are close together. So the sun is at one focus. What is at the other focus if this is the Earth? You're joking. That's almost as worse as last year. They said the moon. The moon goes around the Earth. There's nothing at the other focus. Oh my gosh, this is just basic science, people. Here's the sun, the Earth is going around the sun. So like, sometimes the Earth gets close to the sun. What do we call that? And then over here, this is when the Earth is farthest from the sun. What do we call that? Who's going to be in science bowl? Okay, one is called aphelion. I'm not going to tell you. Well, helion, right? You guys know that's sun, right? Helio. And the other one is called perihelion. One of them means when it's closest to the sun. The other one means when it's farthest from the sun. I'm not going to tell you. Just figure it out. Who takes Latin or what's the other one? Greek. Peri. Okay, let's just move on. That's why we study conic sections, people. And then hyperbola. Is there one for the hyperbola? Yeah. Without hyperbolas, we wouldn't have telescopes. What's a telescope? Oh gosh. Okay, let's just look. Can I assume that you can complete the square and put it in standard form? Or should I just do one? Okay, I'll do it since it's on for the camera. Okay, I'm going to take your Algebra 2 book, which is right here. I'm just going to randomly pick out an ellipse. It's like you guys didn't even learn this before. Okay, where are the conic sections? Trig, conic sections. Oh, there you go. Ellipse. Okay, here we go. Okay, let's pick one that's written in general form. Hey, this one looks juicy. 9x squared plus 4y squared minus 18x plus 16y minus 11 equals 0. Find all the important parts of this ellipse. Okay, before I even start, how do I know this is an ellipse? Just look at the first two terms. Because they're the same sign but different. If they're the same sign and the same number, then it's going to be a circle, right? But once they're different, then it's going to be an ellipse. Okay, now how do I put this into standard form? Put all the x terms together, leave a space. Put all the y terms together, leave a space. Throw the number on this side. What can I factor out from these two terms? 9. So you get x squared minus 2x. What can I factor out from the y's? Okay, equal 11. What do I have to add there to make a perfect square? 1. What do I have to add there? 4. But what did I actually add? I added 9 times 1 because you're going to distribute. So you're going to add 9. And then 4 times 4 is 16. So you have 9 times x minus 1 squared plus 4 times y plus 2 squared is equal to 36. Now, in order to get this into standard form, what do I need this side to be? 1. So how do I do that? Subtract 35 from both sides. No, you divide by 30. What's wrong with you? There. Oh, the bigger number is under the y, so that means the major axis is going to be vertical. This is a squared. The bigger denominator is a squared. The smaller denominator is b squared. So a equals 3, b equals 2. How do I figure out what c is? C squared equals a squared minus b squared. This is probably the most important equation for you. So that's 9 minus 4, which is 5. So c equals root 5. I don't like it to come out to radicals, but sometimes it does. Okay, so here we go. We know the major axis is going to be horizontal, vertical like that. So what's the center? I think I should draw this bigger. Ooh! That's not even. Ooh! Yeah, okay, make that better. Okay, so here's the major axis, here's the minor axis. Okay, what are the coordinates of the center? Is it 1, -2, or -2, 1? It's 1, -2. The x comes first. Okay, what are the vertices? How do I get to the vertices? You go A up and A down, so go 3 up and 3 down. So if I go 3 up, you're going to be at 1, 1. If I go 3 down, you're going to be 1, -5. Tell me if I make a mistake. How do you find the endpoints of the minor axis? You go B left and B right. Well, B is 2. So if I go 2 left, you're going to be at -1, -2. If I go 2 right, you're going to be at 3, -2. How do I find the foci? You go C up and C down. Right? Because the focus is C units from the center. So radical 5 up, so what is this? 1, -2 plus root 5. I don't like that. And then this focus here is going to be 1, comma, -2 minus root 5. Ugly. So Mr. Bart, that's the important parts of the hyperbola. The ellipse. You wish. Now remember, in a parabola, you have a focus. Isn't there a directrix on this side? So if you have a focus, there must be a directrix. But I don't think you guys learned this last time. Okay? So if you have a focus here, there's going to be a directrix there. And if there's a focus there, you're going to have a directrix there. So there's 2 directrices. What is the distance between the center and the directrix in an ellipse? A squared over C. How did you know? You looked at the notes, that's why. So what is A squared? So A squared over C is 9 over root 5. So to get to the directrix, you have to go 9 over root 5 up and 9 over root 5 down. So what's the equation of this directrix? It's a horizontal line. Y equals -2 plus 9 over root 5. What's the equation of this directrix? Y equal -2 minus 9 over root 5. Oh, but Mr. Park, in a parabola, we had lattice rectum, so is there a lattice rectum in an ellipse? Yes! It's like this. Here's one lattice rectum, and here's another lattice rectum. What do you call 2 lattice rectums? See, you can't do that. See, in Latin, there's one focus, but there's 2 foci, right? You got 1 lattice rectum, and ellipse has 2, what's the plural? Who takes Latin? Dang. Is this a class with nobody? Somebody guessed it. 1 lattice rectum, 2 latera recta. Whatever. Anyway, what's the length of the lattice rectum? 2b squared over a. How do you know that? I looked at the notes, that's how I know. You want to do, I can derive all of these if you want, but it's going to take too much. Look, it's almost the end of class already. So you just got to memorize these. 2b squared over a. So 2, what is b squared? 4 all over a, 8/3. The length of each lattice rectum is 8/3. So doesn't that mean this is 4/3 and 4/3, and this is 4/3 and 4/3? So to get to the endpoints of the lattice rectum, you just go 4/3 left, 4/3 right. I think you guys can do that, right? Just to save time. Okay, now there's one other thing in an ellipse. It's called the eccentricity. Basically, the eccentricity tells you the shape of the ellipse. Well, as it turns out, the eccentricity is simply equal to c over a. And what is C over A in this problem? Root 5 over 3. Now, if you look at the three numbers, A, B, and C, what's always going to be the biggest number in any of this? A, B, or C? A, right? Because look, just look at this equation. It's kind of like the Pythagorean theorem, except it's A squared equals B squared plus C squared, right? So A is always going to be the biggest. So if A is always bigger than C, the eccentricity of an ellipse is always going to be between 0 and 1. The closer the eccentricity gets to 0, what does that mean? That means C is very small, right? That means the focus is closer to the center, which means it's going to be more circular, right? But if the eccentricity gets closer and closer to 1, that means the focus gets closer and closer to where the vertex is, and the more elongated it gets. So here's an easy way to remember it. The closer the eccentricity gets to 0, the more it looks like a 0. The closer the eccentricity gets to 1, the more it looks like a 1. So if you look, you guys ever heard of these things called almanacs? I guess not anymore, yeah, because you have internet, yeah. So if you type in, oh, you guys have your iPads now, let's see it. Make it work. Somebody find me the eccentricity of the orbit of planet Earth. Go. Yeah, it's right on your desk there. Yeah, I see it. Eccentricity of Earth's orbit. Go. Come on, we got 3 minutes, 2 minutes. Now, what about the rest of you? Did you guys download what I told you to download? Pocket CAS? Walk? 10? Did you guys try fooling around with it? No, but I got 2 games. So what you're thinking, Chai? Eccentricity of Earth's orbit.
0.0167.
Oh, 0.01. 0.0167. Okay, let's just make 3 decimal places. That's almost 0. That means see, it's almost circular. But it's not a circle. Whereas, okay, wait, don't put it away. Eccentricity of Pluto's orbit. This is what I think it is. Let's see. Is it about 0.25? Yeah. Okay, then what about Neptune? Wait. What's the 8th planet? Is it Neptune or Uranus?
Pluto's still a planet?
No, Pluto's not a planet.
Oh.
Okay, what's the 8th one then? Is it No, it's Neptune, yeah? Okay, eccentricity of Neptune's orbit. 0.008, so that's almost circular. See, that's why you could, okay, so when here's the sun. When Neptune goes around around the sun, I'm gonna exaggerate. It's almost circular. So, but then when Pluto goes around the sun, it's like more like this. So most of the time, Pluto is farther away from the sun than Neptune, but sometimes, because of the eccentricity, Pluto is actually closer to the sun than Neptune, because of the eccentricities of the orbit. Come on, you guys learned that in elementary school, right? Are you serious? Do we even know the planets go around the sun in an ellipse? Do we know that at least? Parabola? You just thought it was all circles.
When I was younger.
You mean yesterday? Oh my goodness. Okay, that's it. Very good. So tomorrow quiz. So we're gonna have 2 circle problems and 1 parabola. Yeah, I think that's enough. 2 problems is enough. And one of the circles I already told you, right? The 3 points, right? Everybody better to get down correct. Oh no, tomorrow, I don't know, man. Tomorrow we might have to go to plan B. I'm getting a bad feeling.